So in order to do that, I'm going to grab the multi-channel pt2 and I'm going to set it to 100 microliters. 100. Then, all I got to do, grab some pipette tips. I'm actually going to move this sideways, it's a little bit easier to work with. And I'm going to start by moving the liquid up and down, just to make sure it's all well mixed. And then pull up 100 microliters, which you can see right there, and then put it back down. Mix it up real well, pull up 100 microliters, move it down, mix it up, pull up 100 microliters, move it down, mix it up, and then I usually go about halfway, then I switch tips, because since we're doing order of magnitude dilution, one tiny drop from here can totally throw off your numbers. So you want to definitely switch tips at least twice, sometimes 3 times, if you know that you've messed up. So we're going to go from dilution number 4. Pull up 100, move it down, mix it up, and to mix I'm just going up and down, and you want to be at kind of an angle where you can kind of see the fluid going up and down, and just to make sure that it looks right. And then again, I probably could be doing a better job of this, but you want to be kind of double checking to make sure everything looks right. So last one. And then you can eject. So this is one complete dilution series right there. So in here we should have 1 to 10, 1 to 100, 1 to 1,000, 1 to 10,000, 1 to 100,000, 1 to 1 million, 1 to 10 million, and 1 to 100 million. So we're just going to repeat that. And this is a real great way of kind of titering anything. It's a very simple experiment you can do to see how many colony forming units you have per whatever volume. It's kind of do it with pretty much anything. So mix it up, pull it up, put it down, mix it up, pull up 100 microliters, inject it to the row below, slosh it up and down, pull up 100 microliters, move to the row below, slosh it up and down. I'm going to eject on this one, replace tips, get a new set of tips. Pull up 100 microliters, slosh it up and down to the next one down. Pull up 100 microliters, slosh it up and down. Pull up 100 microliters, slosh it up and down. And this is kind of the tedious type of lab work.
I can show it to you.
And you just got to be happy that you're only doing with 18 samples as opposed to 1,800 samples. And we're good to go. So now we have our blocks that all have a huge serial dilution in them. So now what we're going to do is we're actually going to plate this. So I'm going to make a little bit of room for myself here. Let's see here. I'm going to get rid of these tips. And we're going to be plating with multi-channel P20. So we're going to be doing spotting. So I'm going to grab my plates here. And we're going to do one block at a time. So we're going to start off with this one. So we have 0, 3, 6, 12, and I've labeled these backwards, so if I flip them around, we see, well, you can't see it, but it says 0, 3, 6, 12, oh, I'm sorry, 0, 3, 6, 12 on the top there. So hopefully these correspond. So I just grab the plates that I need to plate, which are right here, flip them the right way up. And then I'm going to open them up. I'm going to set the top side. I'm going to grab a P20. It's set to 10 microliters. And the reason I'm using 10 is because I always want to be working with orders of magnitude. So I had a 1 to 10 dilution up at top, and now I'm taking 10 microliters of that, which is going to be a 1 to 100 dilution. So 1 to 100 times 1 to 10 is a 1 to 1,000 dilution. So this is a 10 to the minus 3 dilution. So all I got to do is grab the tips and pull up 10 microliters. Oh, this is the wrong solution. So, I'm going to eject those tips. I wanted to use this block down here. Alright, there we go. So I'm going to kind of flip it this way just to make it a little bit easier for me to plate, a bit more ergonomic. I'm going to pull up my highest dilution. It's 10 microliters. And then I'm going to slowly eject, but not touch it quite yet. I'm going to shove it because this takes concentration. So now you see we have a bunch of spots there. And each one of those spots has probably a lot of bacteria. So that's the first dilution, and we have 3 conditions. We have kanamycin, chloramphenicol, ampicillin, and then we just do this for the rest. So I'll just do a couple more just to show the technique. But the idea is that we put each dilution onto this plate, and then we can count how many colonies end up in those spots, and that gives us an idea of how many bacteria we had in the culture to begin with. So I'll just do this a couple more times. And actually, I forgot to show you guys a quick trick, hammering trick. So pull up 10. Oops.
I think I've been doing
Yeah, that was dangerous there, so I didn't fully touch all of my liquid down, and I almost missed a couple data points there. And what I do instead of ejecting the tips, I forgot to do it last time, is I just eject the tips right back in there so I don't lose track of where I am. So I'll just do this a couple more times. So, whoops, pull up 10 microliters.
That's the problem, it's all microscopic, there's no tangible way of knowing exactly what's happening.
And eject the tips. So then we'd just do this for the rest of these rows, and we're going to end up with a plate that just has a bunch of rows on it. And you can see on this plate, I have kind of a wet plate, so some of the samples are running into each other. That's no good. That means I've lost those data points. We want to try to avoid that if possible. But we'll just do this for the rest of the plates, and then tomorrow we're just going to be able to count colonies and back calculate how many colonies I had, or rather how many bacteria I had in the original culture.